Now we know about the types of data, so let me explain a little bit about collecting data. A few minutes ago, I mentioned that instead of surveying an entire population, we would need to take a subset of that population called a sample. And if we sample correctly, which can sometimes be a hard thing to do, then we hope that our sample has representative features of the population. So you might ask, why is sampling as good as surveying the entire population? Or you might say, I don't think that's as good. I think that I really need to survey everybody. Well, if you think about it, to survey everybody in a situation might be difficult or even impossible. Or maybe if it's not impossible, it's a real pain to do, or it would be very expensive or take too much time. And also in some cases, it doesn't really matter. So for example, let's say you're baking a batch of brownies and you want to see if the brownies are done. When the timer goes off, you open the oven and stick a toothpick in the center. If it comes out with brownie guck all over it, you might decide, I need to cook my brownies a little more. But if the toothpick comes out completely clean, then you might decide, well, I don't really need to cook the brownies anymore, so I'll take them out of the oven. Now, sometimes for people who are a little bit neurotic, what they might do is say, gee, I know the toothpick came out clean, but I'm going to poke it in one more place and see how it is. And if it comes out clean, then I'll know that I'm done. So the question becomes, how many more, if any, places do you sample the brownies until you decide that it's done? Maybe you sample 3 places, 9 places. And what if you sample 9 places and the toothpick comes out clean? Should we continue to do 200 or 500 places? Well, if you do that, what happens to your tray of brownies? It doesn't work very well because your tray of brownies has ended up as brownie crumbs. So we've decided that if we sample in the middle or sample 1 or 2 places, that's as good as serving the entire population of brownies. Here's another example. Have you ever gone to the doctor and the doctor says, I need to take some blood from you to run some tests? Then you go and they take a small tube of blood. They never say, oh, we need to take all your blood today to run some tests. Come back tomorrow, we'll put it back inside you. Now, I know that's a ridiculous example, but you see, only taking a little tube of blood is considered to be a valid representative of how all the blood in your body might be. Those are just 2 types of examples. So now the question comes up of how should we sample? Well, there are some really bad ways to sample. That's the easy thing, is to come up with the bad ways to sample. But there are also a bunch of good ways to sample, and I have a few sampling techniques that I want to discuss. So for sampling, the first thing we have to decide is, are we going to sample with replacement or without replacement? With replacement means that as soon as we pick a value, we put it back in to be picked again. Without replacement means that when we pick a value, it stays out of the sample for good. For example, if you've ever played the lottery, then you know that when a number is chosen, it's not put back in. That's sampling without replacement. If they were to put it back in, that would be sampling with replacement. Whether you sample with or without replacement typically depends upon what type of survey you're interested in doing and what it is you want for your end result. So if I were to pick a group of students to be on a committee, and I wanted somebody from every single course on campus, and a person, let's say it's called student X, happened to be taking both math and English, and I picked that student X from the math class, then I probably wouldn't replace them. Then I'd go and pick from the English course, making sure that student X was not part of the selection. All right, that's the first part of sampling. Now from here, we want to make sure that our sampling is representative of our population. So let's think about what that means for just a minute. Let's go back to the example of where we were surveying to see how long it took students to transfer. In this case, if we only surveyed students who transferred to Penn State, we would be surveying a large number of our students, but that's not representative of all students who leave Mason and transfer. So that would be a poor type of a sample to do because of the fact that students do transfer to other places. The same would go if we only surveyed students who transferred that were engineering majors. Again, that would be a poor survey to do because we want to make sure that our sample is representative of all of the people who transfer. So how do we make sure that our sample is representative of our population? There are several different ways. First, our goal is to have random sampling. There are four main kinds of random sampling. First is simple random sampling. An example of this might be where you put everybody's names on a piece of paper and you put it in the hat, shake it up, and then you just pick a bunch of names out. You could do that with replacement or without replacement. You could also use a random number generator to generate numbers. That would be a simple random sampling with replacement because a number could be picked more than once. Next, there's stratified sampling. Stratified sampling is where we divide areas into different stratum. For example, let's say we want to pick two students from every class on campus. I would take each class on campus, each class being the stratum, and I would pick two students from each group, and that would be a stratified sample. So everyone has a chance of participating, and in each class I pick two students. The next type, cluster sampling, is slightly different. What we do with a cluster is we would take all of the classes on campus and randomly pick a few classes. So maybe we pick accounting at 7:30, US history at 2:30, and speech at 8:30. We take just those three classes, and within those three classes, we survey all of the members of those classes. This is very much how some major studies are done when focus groups are being studied. What they do is focus on one part of the population or one regional area and survey everybody in that group to gain some information. The last type would be a systematic type study. With a systematic study, what we do is start someplace random on a list and possibly pick every nth name on the list. So for example, let's go back to the case where we're interested in how long students spent at Mason before transferring. In this case, we might just start someplace. Somebody might give me a number 3,000, and I look at the 3,000th name of all students who have ever transferred from Mason, and then from there I might call every 20th number going down the list, or every 25th or every 30th number. So it's a systematic approach to doing that. So these are the types of random sampling, and our goal is to get our sampling techniques to follow one of these. Now, most often, though, what we find is that we use what's called convenience sampling. This is not random. This is a type of survey where you're just walking around and you say, hey, I'm doing this survey, can you help me out? Can you answer this question? And there is value in convenience sampling, but it is usually not a way that you're going to end up with a sample group that's representative of the population. And that is the big problem with this. So if we were to do a survey on campus of how long it took students before they transferred, and we just walked up to a random group of students, then we're excluding everybody else, and this group may not be representative of the entire population. Or if we walked into a class at Penn State and said, excuse me, I'd like to do a survey. If anybody here is from Mason, how long did it take you before you transferred? Well, even though we think it might be representative, it may or may not be. Convenience sampling, though, is often what's used in advertising and in studies that are published in the newspaper, even though they're usually not very accurate.